Okay, so here we discussed increasing, decreasing, and constant. And these were the notes we had, and if you need to take these notes down, just pause the video and copy them down. But basically it's increasing, and we always read graphs going from left to right, just like we read words when we're reading a sentence. So we're always going this way. Basically, as we go this way, if the y value is getting bigger, then it's an increasing. I think about this as it's going uphill. Uphill, increasing. As I go from this side to this side, if the y is getting smaller, in other words, it's going like this, that's decreasing. And I think about that as going downhill. And constant, something that's constant is not changing. So as I go across this way, y is staying the same. So this one is one where it's just going straight across, and it's not going uphill or downhill. So let's see how this works on some examples here. So I find this easiest if you just look at one part or another. If I start here on this end, and I always suggest to just cover up the very arrow. We just know that it keeps going this way. But if you cover up the arrow, it kind of helps you to think about this, because we're not going that way. We're always going this way. So if I look at this part is going uphill. So this whole part from here at the end, all the way till I get over to here, this is going to be increasing because it's going uphill. Then this middle part from here to here is going downhill. So I'm going to do a different color there for that. This part starting here and going to here, downhill. So this part is decreasing. And then this last part is going up again. It goes up very high. So this part over here is again increasing. Now I could use interval notation, or I could use my inequality notation. I'm going to give the interval notation. So I'm going to do this first part here. It's from negative infinity to -2. And I'm not going to include the top, because at the very top, is it going uphill or downhill? Well, at the very top, it doesn't really make sense to say either one, so we're not going to include that top point. That's where it kind of goes from one to the other. And then I'm going to include the other pink part over here from 3 all the way to infinity. My decreasing is the middle part here that goes from -2 to 3. That's the green part. Now we're going to add some extra words, maximum and minimum. And here we're going to talk about local or relative max. I know that it really keeps going forever in each direction, but we're going to just talk right here in the middle what happens at each one of these little places. Since f of x is increasing on this side of -2 and decreasing on this side, then we say it has a local relative max. So not the whole thing, but just in this little area right here, this point is a maximum. And that's what we mean by local or relative. We just mean in this little tiny area here. And then on the other side, we have, since f is decreasing on this side and increasing on this side, that makes this a relative min. So since it's decreasing on this side and increasing on this side, it makes it a relative min. And I skipped this extra question because it says the maximum is at -2, and then what is the maximum height? The maximum height is 4. And then this says the minimum happens at x equals 3, and what is the minimum? So what is the y value? Well, it's 0 right there. So let's just practice that with a couple of examples. Here's our first one. And again, let's just say this has arrows on it. I think I accidentally cut those off when I started this. So it's going to start over here, and this first thing goes all the way to here. And is that an increasing or decreasing? Well, this first part is going uphill. If I was going along this way, that'd be uphill, so this is an increasing. Then this next part from there to there, this is a downhill, so this is decreasing from here to here. Then from here to here, it would be going uphill again, so that's an increasing. And then from here to there, it's going downhill, so that's a decreasing. So let's do each one of these. So the increasing is the pink parts from negative infinity to -7. And I'm not including the top part because we said that's where it changes from one to the other, so we can't include that. And it goes from 0 to 7. And then on the negative part, let's go ahead and do, oh, it doesn't say ask us to do the decreasing. So then it says, at what values, if any, does it have a maximum? Well, there's a maximum right here and a maximum right there. So that's at -7 and +7. The word maxima is just plural for maximums. We don't say maximums, we say maxima. So that's just the plural. Where is this maximum? How tall are they? Well, they're both the same height, and they're at the y value of 3. Now, at what values do we have a minimum? Well, the minimum happens right here at x equals 0. And the minimum height is -4. And then it says, where is the whole value, the y's, bigger than or equal to 0? Well, the y's are bigger than or equal to 0 anywhere above the x-axis. So it happens right here in this section, and I'm going to use a different color for it. So it goes from here is where it becomes bigger to there. And then it happens over here again. It goes above here, and it goes from here to there. So here is -9. So I'm going to start at -9. And it goes from here to here is where it goes back below, so that's -4. And this one says or equal to, so I want to include the points on the line. So I'm going to put the square brackets here. And then over here, we'll start at 4. And we'll go from 4 to 9. And one last graph we have here. Okay, so first of all, is it a function? The only place there might be a problem is right here if I do a vertical line test. But since this point is not included and that one is, it would still only touch in one place. So that's a yes. My domain would be everything. This is okay because there's a point there. The only point that's not included is this point right here at -3. So I'm just going to say x not equal to -3. My range, if I start up here, it's got an arrow, so it would start up here, it would include everything, would it include this point here? It doesn't look like it on that part, but if I come over here, it does get included on this point, so this would be everything from there all the way down to this point, and then there's nothing below here, so this is at -3 and up, so that's y greater than or equal to -3, because that's here and up. F at 1, so this is x, and then this is y, so where is x1? X is 1 at 2, and y is 1 right here. Oh, it's 3 places, right? So we've got 0. Oh, it's not actually here at 2 because that's an open circle, but it is right here, and we'll call that 8.3. So at 0 and 8.3. And where is y 0? Well, y is 0 right here on the x-axis, so this is at -1, 4, and 8. And then where is the function less than 0? Less than or equal to 0? Well, it's everywhere below this line. So it's everything on this side of -1, so where x is less than or equal to -1, and from here to here. So this section is, I'm going to write this in my inequality notation from 4 all the way to 8. Where are my zeros? Well, remember zeros are another way to say roots or x-intercepts, so it's at -1, 4, and 8. The y-intercept, where it crosses the y-axis, is at 1. Is this function 1 to 1? Remember, 1 to 1, I could draw a horizontal line test, but right here I'd hit 2 points, right here I'd hit 2 points, so this is a no. Relative max. If it's increasing on both sides, leaning toward a top, then it's a relative max. So this right here would be our relative max. Because it's increasing on this side, well, increasing on this side, decreasing on this side. So this is our relative max at 2. Relative min, well, Well, this is constant, so that's not a min, but right here is a min because it's decreasing and increasing those, so that's at 7. Now, where is it increasing and decreasing? Well, I'm going to look for uphill parts. Uphill parts start right here, and this part right here is uphill, going uphill. So that goes from -4 to 2. Not including this little guy. Well, this little guy right here, we can go ahead and just include it because it is increasing in that whole area. So -4 less than or equal to, now we could just do less than because it shouldn't probably include this bottom point. So less than x all the way up to 2, less than 2. Decrease, and then we also have this piece over here that's increasing from here over that way. That is at x is greater than 7. Now our decreasing is in between there. So decreasing would be from here to here is decreasing. So that's from 2. I'm not including the end all the way to, oops, this is x less than 7. Where is it constant? Well, it's constant right here on this part, which is x is less than -4. Find f at 2, so that's where the y, the x is 2. The x is 2 here. Ooh, which one should it be? Should it be this one or that one? It should be the colored in one, so that's 3. And then estimate where the function is less than 0. So that's anywhere where the whole line f of x is less than 0, so below the x-axis. So over here, it goes all the way till I get to here at -1. So this is where x is less than 1, -1. And then it doesn't go back below till I get here. This starts at 4 and less than x, and it goes all the way over here till 8 is less than 8. I'm not including the equal signs here because this doesn't have an equal sign, so I don't want where it's right on the line. I just want where it's below.